All right, this is going to be the last page. Number 25 says to define a variable and write an inequality to model the following situation. A person must be at least 18 years old to vote. So we could say maybe P stands for my person. And if I have to be at least 18 years old to vote, I have to be at least greater than or equal to 18. Okay. Number 26 is a little tricky. I would suggest drawing a picture. It says if x is greater than -2, so if I have a number line here, and at -2, if x is greater than that, so x is going to be my black highlighted there, and then I'll do my y in red. So at 1, it's going to be less than. Okay, it's saying now, when is x and y multiplied together greater than 0? Is there ever going to be a time when they're greater than 0? Well, if I picked a number like, for x, maybe -1, and I picked a number for y that was also negative, maybe like -3. If I were to multiply -1 times -3 together, I'm going to end up with a +3, which is in fact greater than 0. Okay, that's a true statement. Now, I could have picked a number, instead of -3, I could have picked 3 over here. Well, if I have x, which is -1, and y, which is 3, that gives me -3, which is not equal to 0. So, this is sometimes true. And it's only true when either both of them are negative or when, I ran out of space, when x is greater than 0 and y is in between 0 and 1. That would also give us a positive number. Okay? Number 27, it says a teacher knows a majority of her students will score within 5 points of the class mean of 80%. Write an inequality that represents the test scores for the majority of her students. So we can assign a variable called t for test scores. And if my mean is at 80, 5 points higher than that would be 85. 5 points less than that would be 75. So anything in between 75 and 85 is going to represent that inequality. So instead of having 80 in the middle, we're just going to have a variable t, and it has to be less than or equal to 85 or greater than or equal to 75. All right, last one, number 28. My test scores in math are 77 and 79. What possible scores can I earn on the next test to have a test average between 80 and 85 inclusive? Write your answer in interval notation. Okay, so there's kind of a lot of things going on here. Writing this as a compound inequality, it's going to be an and compound inequality. My test averages are going to go on the outside. So my test average of 80 and 85 go on the outside. My test scores average goes in the middle. I've got my 77 plus 79 plus some test score that I don't know of, and I need to divide that by how many test scores I have, which is, in this case, 3. Now from here, all I need to do is solve for x. So first thing I need to do is get rid of that dividing by 3. So I'm going to multiply by 3 on all sides. And when I do that, I get 240 is less than or equal to everything that's in the numerator, because those will cancel. And 85 times 3 gives me 255. Okay, on the middle here, I can go ahead and combine these like terms, 77 and 79. If I add those together, I end up with 156. So let's go ahead and replace that with 156. And then it's just a one-step inequality. I got to subtract the 156 from all 3 sides. And when I do that, on the left side, I will get 84. In the middle, I still have my test score of x, and on the right side, I have 99. Okay, now let's go back and read the question. There is no question that we really need to answer. It just says what possible scores my possible scores are anything in between 84 and 99 on the test. And if I were to write that in interval notation, since they both have since they both have lines underneath the inequality symbols, I know I'm going to have to use a bracket. So 84 to 99, bracket around both of those. That would be my answer in interval notation.